Okay, so solubility rules. What dissolves, what doesn't. So that's what we're going to be looking at in today's video. But first, I've got a quick quiz for you. So if you can pause the video and then have a go at answering the quick quiz questions. So I'm going to start the video again in 5 seconds. 3, 2, 1. Okay, actually pause it and do these questions, right? Make sure you've done them. Okay, so what does the state symbol AQ mean? So AQ means aqueous. I can't spell it all today. Right. Means aqueous, means something is dissolved in water. Right, calcium is a metal. Metal plus acid makes salt and hydrogen. So we know that one of these is going to be hydrogen gas, hydrogen. And what salt is it going to be? Well, it's calcium and it's hydrochloric acid. So it is calcium chloride. Right. What ions are found in acidic solutions? So the ions that you find in acidic solutions are H plus ions. How can you separate a liquid and an insoluble solid? So insoluble means it's not dissolved. So that would be filtration, because you can filter the solid out. And how can you separate a solute? A solute is something that is dissolved. So how do you separate a solute from a solution? So that would be crystallization. So you evaporate the solvent, the liquid part, and it leaves behind the solute as crystals. Right. So back to the bulk of today's video. So solubility rules. What dissolves, what doesn't. So a quick recap on state symbols. So for state symbols, you've got an S, which is where something is solid. You've got an L for where something is liquid. There is AQ. This is very different from liquid. AQ is talked about in the quick quiz. Aqueous, it is dissolved in water. And then G for gas. Right. So if something dissolves, so for instance, sodium chloride, NaCl is sodium chloride. That's salt, table salt that you put on your food, on your chips or whatever. So that's table salt. If you put it in water, it does dissolve, so it would be aqueous. So that is soluble because it dissolves. And there are 5 rules that you need to memorize. There's no real shortcut for these. 5 rules that you need to memorize around which types of substances dissolve and which don't. So these are the 5 rules. So the first one is that all common sodium, potassium, and ammonium salts are soluble. So it doesn't matter what the second part is. So sodium chloride, sodium bromide, sodium fluoride, sodium nitrate. Doesn't matter what the second part of the salt is. If it's got sodium as the first part, same for potassium, same for ammonium. So ammonium chloride, ammonium nitrate, whatever. All of these, they're soluble. So second part, B, is all nitrates are soluble. So it doesn't matter what the first part is. Iron nitrate, lead nitrate, copper nitrate. The nitrates are soluble. So C, all chlorides are soluble. And there's a couple of exceptions here. So it's similar to the nitrates one, but this time the chlorides, there's a couple of exceptions. So except silver and lead. So lead chloride is insoluble, it does not dissolve. Silver chloride is insoluble, it doesn't dissolve. D is sulfates. So all sulfates are Soluble. Again, there's some exceptions, and the exceptions here are lead, barium, and calcium. Okay, and E is all carbonates and hydroxides are insoluble, so none of them dissolve. Except, and there are 3 exceptions. Hopefully you can work it out. If we looked up here, we said all sodium, potassium, and ammonium are soluble. So all carbonates are insoluble except for these 3. So except sodium, potassium, and ammonium. So it seems like a lot to remember. In reality, the first one and the second one do link quite closely together. So if you got asked some examples, I would recommend, actually, just come back to this one, I would recommend that you guys pause the video and just jot these down. So nitrates are things that have NO3 minus, so chlorides is Cl minus. Sulfates, they are SO2 2 minus. Carbonates are CO3 2 minus, and hydroxides are OH minus. So sodium, Na plus, potassium, K plus, and ammonium. This one's a little bit different. Ammonium is NH4 plus. That's supposed to be a bracket there. Right. Worth writing these rules down because we're going to be referring to them a lot. So pause the video and just jot these down. I'll give you an actual chance to pause it. Right. So, sorts of questions you might get asked. So if we have let's say lead nitrate plus sodium chloride. Right. What's that going to do? What's that going to make? So lead nitrate plus sodium chloride. So, okay, so let's say they swap over. So we end up with sodium nitrate, and I've run out of space, but sodium nitrate and lead chloride. Well, what would the state symbols for these be? What would you see if you did this as a reaction? So let's check out lead nitrate first of all. So lead nitrate, if I come back to my rules, all nitrates are soluble. So lead nitrate, that one would have been, and I know normally you shouldn't put state symbols on word equations, but I'm just going to do this because it's just a bit quicker. So lead nitrate would have been aqueous. It would have been dissolved. Sodium chloride. So we check. Well, all chlorides are soluble, but also it was sodium, and all sodium things are always soluble. So sodium chloride, that one would have been soluble. Then we look at sodium nitrate. Well, hopefully we remember from rule A, sodium nitrate, all sodium things are soluble. So we put AQ. And then lead chloride. So this is where, if you've written this down, this is rule C. So if you go back, so if you look at rule C, all chlorides are soluble except for lead. So that means lead chloride would be a it would be insoluble, so it would appear as a solid. That's called a precipitate. I'm just going to pause the video. Well, you guys don't have to pause it. I'm going to, hopefully you'll see through the magic of brilliant editing, a little practical now. Okay, so we've got a slightly different equation here. So we've got magnesium sulfate plus sodium carbonate, because we've got magnesium sulfate, and I'm going to react it with some sodium carbonate. So magnesium sulfate plus sodium carbonate. If we check our rules first of all, I mean, you can tell by looking at it, so sodium carbonate, totally soluble, and magnesium sulfate also totally soluble. And if we check our rules, so magnesium sulfate, if you look at rule D that you wrote down earlier, so rule D, all sulfates are soluble except for lead, barium and calcium. Well, we've got magnesium sulfate, so that one will definitely be soluble, which would be AQ, because it's soluble. Sodium carbonate, well, first rule. Rule A, all sodium salts are soluble. So sodium carbonate will definitely be soluble. So I'm just going to write down an AQ. Right. I didn't have a space to write this as one long equation on my board, but it goes to sodium sulfate. Well, same as rule A. Sodium sulfate is sodium, so it's soluble. I mean, it also comes under rule D. All sulfates are soluble except for lead, barium and calcium. But, you know, we've got rule A as well, which was the all common sodium salts are soluble. So sodium sulfate, definitely soluble. AQ. So obviously in this reaction, we're just swapping magnesium sulfate, magnesium bonds with the carbonate, so we make magnesium carbonate, and then the sodium bonds with the sulfate, so we make sodium sulfate. Right, last one, magnesium carbonate. So when we look at rule E that you wrote down earlier, mine have got a little bit smudged. So rule E, all carbonates are insoluble except for sodium, potassium, ammonium. So carbonates are all insoluble. So carbonate is going to be insoluble because that is magnesium. It's not one of our exceptions, which means that will form an insoluble solid. And that insoluble solid that it forms is called, and I'll hold this up so you can see it, it's called a precipitate. Precipitate. So when you get a precipitate, it means you've mixed two solutions and created a solid. So we've got an aqueous solution, and when we mix them together, yes, that one is going to be aqueous, but this one is going to be solid. So we will make magnesium carbonate, which is a solid, which we call a precipitate. So if I show you here, so I've got my magnesium sulfate, so I'll pour some into this one. Then I've got my sodium carbonate, pour that into this one. And then when I add this one to that, right, and it looks like a white solution, but what actually you have there are tiny particles of a solid that is suspended in the solution. So if I leave that for a while without wobbling the table or picking up the test tube at all, gradually all those particles of solid will sink to the bottom. You know, like a snow globe, when you shake a snow globe, all the little bits of, you know, they're not snow, but snow fly everywhere, and if you leave it, they all settle to the bottom. It's like that, except they're all really fine. If I go a bit closer, I can get it to focus, then you can see the little, it's a suspension of tiny particles of solid in there. So I'll leave that, and then I'll include a little clip, sort of, not a time lapse, but I'll include a little clip after I've left that without shaking it for a while, so you can see that it is indeed a solid. And the name for that solid is a precipitate. Okay, I realised that there's something else that I can use this experiment for whilst I've got it. So, I mean, if I come in a bit closer, it hasn't had time to fully settle yet, but you can kind of see there is definitely a solid in there, right? And I'm just trying to balance this. Right, so we mixed, if you remember, well, of course you remember because this was about 20 seconds ago for you, but it's about half an hour ago for me. Right, magnesium sulfate and sodium carbonate, and so we ended up with sodium sulfate, which is soluble, and magnesium carbonate, which is insoluble. So that's what the solid is. And let's say, for argument's sake, you wanted the magnesium carbonate, you wanted to keep that as a pure salt. So it is an insoluble salt. We know it's insoluble because it's made a precipitate. It's made that solid precipitate. If you want to make a pure insoluble salt, you filter it. So we can get that there. Just filter paper, and I can filter this through. Pull that out to there. And what should happen if I give this long enough time is the water should filter through. So the water should filter through, and the water, remember, will have sodium sulfate dissolved in it, and that will leave the magnesium carbonate in the top. So if I zoom right into the bottom, so you can see when it's dripping through, it's totally clear. So that will be in the bottom, we'll have water with sodium sulfate dissolved in it, and then in the top, when it eventually all filters through, we will be left with magnesium carbonate. But the problem is the magnesium carbonate will not be pure because it's going to be wet, right? When all the water's filtered through, there'll be a solid left in the top, but the solid will be wet. And the water that's there making it wet will contain some of the sodium sulfate dissolved on it. And we don't want that. We need to get rid of the sodium sulfate because all we want is the solid magnesium carbonate. That is the only thing we want. So to get a pure insoluble salt, you filter that off, and then what you have to do at the top is wash it. So we wash it with some distilled water. So this is totally pure water. It's not tap water, totally pure distilled water. It's only got water in it. And then you wash it with that, which means you're washing through anything that was on there that is soluble will wash through into the bottom, and you keep washing it, and then in the end, when you let that dry off, the only water that will be left up there will be totally pure water. So the pure water will evaporate away and just leave you with the salt that you want. Right, I'm just going to come back across to here. So the very final part of today's lesson with the solubility rules is making predictions. So you need to use your solubility rules to make predictions over what you'd expect to see, or predictions for state symbols. So if we look at this first example, right, we've got CaCl2. If you were given this, don't worry too much about the numbers. What have you got? Calcium and chlorine. So that is calcium chloride. So you know it's got a chloride salt. We're going to have 2Pb NO3. So if you looked at a periodic table, Pb is lead. NO3, we talked about it earlier, if you'd written down your rules. NO3 is nitrate. And then that is going to make, remember we just swapped them over, so that is going to make calcium nitrate. Don't worry too much about the numbers at this point. You're just more interested in, right, it's calcium and it's nitrate. So calcium nitrate, and it's going to make lead chloride. Lead and chlorine. You might get asked to put state symbols to these. So hopefully you've written down the rules from earlier. If you haven't, rewind the video back to it and write down those rules, because I'm not going to keep switching backwards and forwards. But if you look, rule C, all chlorides are soluble except for silver and lead. Well, that's not silver or lead, it's calcium, so that will be soluble. So it is aqueous because it's dissolved in water. If you look at rule B, all nitrates are soluble. No exceptions. That's lead nitrate, so it is soluble, AQ. Calcium nitrate, again, rule B, all nitrates are soluble, so that is AQ. And then chlorides, rule C, all chlorides are soluble except for silver and lead, and that is lead, it's lead chloride, so that will be solid. It will appear as a precipitate. It will be a solid precipitate. What I would like you guys to do now, I'm just going to show you another example here, if I can actually pick up this whiteboard. Right. I'd like you guys to have a go at doing this one. So you've got Cu is copper, copper chloride, K is potassium. You can use periodic table. Potassium carbonate. Remember, CO3 is carbonate. It's rubbed off from now, but if you rewind the video, it was written there. And then we've got copper carbonate and we've got potassium chloride. I'd like you to try and add the state symbols in here. So pause the video and have a go. And I'm going to go through the answers now. So if you haven't, make sure you have paused it and tried it. So copper chloride, all chlorides are soluble except silver and lead. So that one's definitely soluble, AQ. Don't do S for soluble. Remember, S is solid. So that is AQ. Carbonates, all carbonates are insoluble except for potassium, sodium and ammonium. So that's potassium. So that one is soluble, AQ. Copper carbonate, this one's now insoluble because carbonates are all insoluble except for R3, sodium, potassium, ammonium. So that one is soluble. And chlorides are all soluble. So that one is AQ. So you need to be able to use those rules as a prediction. So it's worth learning them. Whilst there's 5 of them, remember the first and the second one, sorry, the first and the last one do link together. And then I'm just going to go you across just so you can see a little bit more. So that's what we've made, and it's, if I can get it to focus, so it's totally clear at the bottom, and at the top we've got our, I'm not sure I can get that to focus. There we go. That is a solid, right? And it's not fully, it's not dried yet. So that won't be pure yet because it will have some of the, remember that's not pure water, it's got the soluble salt in it. So this will have some of the soluble salt. So what we should do is like leave that for a while till as much of the water's gone through as we can, and then wash it with more distilled water to make the pure salt.